Professor Glasser's survey course in conceptual mathematics seemed like a good idea at the start of the term. No graded homework, no midterm exams, just an oral final at the end. As the semester progressed, cutting a few classes didn't really seem to matter. Neither did skipping a reading assignment or a homework set here and there. But a few here and there slowly turned into several, which turned into most. Eventually, you were too embarrassed to show up to class anymore. And for the better part of the second half of the term, you did an impressive job of forgetting about the final exam. Until this morning. Cramming has never worked for you, but what choice did you have? You already made your choices, you suppose, repeatedly throughout the semester. Blaming yourself now isn't going to do any good, though. You can blame yourself all you want after tomorrow. Focus on the final. Focus on the final. How, though? It's late. You need more sleep, but you're not sure you remember much. Anything from today's library cram session. You've got to pass that final because you've got to pass the class. What will happen to your scholarship if you don't? With these pleasant thoughts running through your head as you walk across campus, you finally return to your dorm room. Apparently, your roommate moved out today. The room looks pretty bare with only your stuff left in it. Not that you had much to begin with. The only decorations that remain are a few of your posters hanging on the walls. You hear loud noises coming from the hallway to the south. It sounds like your hallmates have begun celebrating the end of the academic year. You can see your bed and your desk, on which are a medicine bottle and a note.
Read note.
It's from your roommate. Good luck on your final. I've left you the last of my study pills. I promise you they are perfectly safe, all natural and organic, although they may not work exactly like you expect.
Examine bottle.
These study pills are ones that your roommate picked up at that sketchy health food store downtown. Your roommate swears by them, but you've always been skeptical. The bottle is closed, and there is something written on it.
Read bottle.
On the bottle is written, Blorple pills explore a nearby object's mystic energy field via the power of dreams. Mystic energy field? Power of dreams? You thought these were supposed to be study pills.
Open bottle.
You push down on the bottle's cap, twist it, and pull. And the bottle opens easily. Phew. Sometimes these child-proof medicine bottles are really hard to open. There is one pill left in the bottle.
Take pill.
A bit hesitantly, you swallow the pill. Hopefully, this will help with your studying.
Study.
You open your math book once more and begin to read. You can't seem to focus, though. Whatever that pill is supposed to do, it's not helping your concentration. What did it say on that bottle again? You are feeling sleepy.
Read bottle.
On the bottle is written, Blorple pills. Explore a nearby object's mystic energy field via the power of dreams. The phrase, an object, catches your eye. You continue to feel sleepy.
Sit on bed.
You get onto your bed. You are feeling sleepier.
Sleep.
You curl up with the math book. Whether by exhaustion or the effects of the pill, or both, you quickly fall asleep. Your dreams are strange. Images from today's Cramfest run through your mind in rapid succession, combining, reforming, and producing new images, each of which sinks into your unconscious. Eventually, your thoughts slow down, and as they do, you can feel your mind empty. Your dream coalesces into point. You find yourself in a deep, dark blue, almost black, expanse of space that extends as far as you can see in all three dimensions. The only thing that breaks up this space is the white disk floating in midair that you are standing on. While the disk doesn't appear to be supported by anything, there is a hole in the middle of it.
This is Relatively Prime, interactive fiction in the mathematical domain. I am Samuel Hansen. What you just heard was the opening to A Beauty Cold and Austere, a mathematical interactive fiction game created by Mike Spivey, professor of mathematics at the University of Puget Sound. And if you don't know what interactive fiction is, well, let's let Mike define it for you.
Definition of interactive fiction. So I think that's actually something that's contested. Different people have different ideas of what interactive fiction is.
Okay, so that didn't quite work. I guess I'll give it a try instead. Interactive fiction was originally coined by the game designer Robert LaFleur, and then it was popularized by the game company Infocom as a new term for their games, which had been previously called text adventures. These were games which primarily used text, both to describe the world the player is in and as the way the player interacted with that world. Early examples of these text adventure games include the very first one from 1975, Adventure, aka Colossal Cave Adventure, Zork, where the immortal line, "It is pitch black. You are likely to be eaten by a grue," came from, and even an interactive fiction version of The Hitchhiker's Guide to the Galaxy, which Infocom made with Douglas Adams himself.
I was a teenager in the 80s, and many of the best computer games of the 1980s were interactive fiction games. The graphics weren't that advanced technologically, and so many of the best stories, the best games that I played, certainly the ones that were the most interesting from a story standpoint, were the interactive fiction games that Infocom was putting out.
While the advent of graphics engines and faster machines did cause these text-based games to decline in popularity, interactive fiction is still sticking around.
Bogeyman was a recent, very well-received choice-based game. Depression Quest, which was behind the Gamergate controversy a few years ago, can also be considered interactive fiction. And then also film, in which the reader is faced with choices to make for the direction the film is going to go. And there have been a few experiments in that direction, the most famous of which is probably the Bandersnatch episode of Netflix's Black Mirror series.
Mike clearly has a soft spot for interactive fiction, but there still seemed to be something missing for me. Specifically, what exactly it was that made him think that interactive fiction and mathematics would be a good match.
Yeah, that's a really good question.
Part of the answer that Mike gave to this really good question harkened back to the early text adventure games and how they often drove the story forward using intellectual puzzles. And who is to stop someone from making those intellectual puzzles mathematical in nature? Which leads us right up to the other part of Mike's answer.
The thing that really gave me the idea was another game from Infocom, published in 1986, called Trinity. And in Trinity, there is a place in the game where you are in a magical garden, and there is an arboretum that's in the shape of a Klein bottle. And you have to understand inside the game what the properties of a Klein bottle are to solve one of the other puzzles in the game. And I thought that was absolutely fascinating, that you could take a very advanced mathematical concept, put it in a text setting, and basically teach the player some of what a Klein bottle actually is, and have them use that to solve a puzzle.
And that's not all. Mike had a pedagogical reason, too, for wanting to create the game.
Learning an idea because you have some sort of motivation. It's helping you solve a puzzle in a game. What a great way to teach any ideas, really, not just mathematical ones.
Teaching people mathematical ideas is something Mike is very invested in, especially in teaching mathematical ideas in new and unique ways, and reaching populations outside of the typical classroom. Something he thought this game might just be able to accomplish.
By writing a game, this could be something that would get some mathematical ideas, hopefully maybe, in the heads of people who wouldn't normally ever encounter them. And maybe it's a small community that plays interactive fiction, but there's still, dozens, hundreds maybe of people who might pick up A Beauty Called an Austere and learn some mathematics from that.
But come on, let's be honest here. We all know why Mike really made this game.
I guess I wrote it partly because it was the kind of thing that I wish I could have played when I was 13. I would have loved to have had something like this.
And that right there, that really is the best possible reason that I can think of for designing a game. Now, when I asked Mike more about designing A Beauty Cold and Austere, he said he wanted to make sure that there was more to it than just arithmetic and algebra. He wanted to show how much more there is to mathematics, like combinatorics, probabilities, sequences, and series. And this gave Mike an idea of the content. But there was still the question of how to present this content, how to attach it to the game's world.
Well, maybe it made sense to do the mathematics historically. That gives me now a way to piece together things in a particular order. And so before I made a physical map of the story world, I made a concept map for mathematics, like which mathematical concepts came early historically and which led to other things. So, for example, algebra and geometry together needed to have been developed before calculus could come along. Or probability needs to have some combinatorics behind it before you can really do probability well. And then also mathematical concepts that may not be required to come from other particular concepts. I was still able to use sort of the overall historical development to create this concept map. And then I based the physical map of the game on the mathematical concept map.
Which of course raises the question, how exactly do you represent these mathematical ideas as puzzles in the game's physical space?
I'd pick a concept like linear algebra and think, okay, so what aspect of linear algebra do I want to implement? Okay, so matrices. Matrices can be used to do transformations. So maybe I can implement something in the game that sort of features matrix manipulation, maybe a machine of some sort that would transform objects based on the way the matrix is set up. So maybe the matrix could invert the object's orientation, or it could flatten the object, or the various other things that matrix transformations allow you to do. But then you can actually implement that physically in the game. You can make the thing flat, or you can make the thing reverse orientation by applying it through the in-game, through the matrix transformation machine.
Research lab wires and pieces of metal indicate that highly complex experiments must have once been performed in this room. Now, though, they lie scattered haphazardly here and there. Someone has cleared this space out. There are open doors to the north and south, and the exit to the lab lies east. A door to the west is closed. Not all of the experiments are gone. Near the west door is a platform, raised slightly off the floor. A control panel is attached to the wall near the platform. There is also a large fan set into the east wall. A printout has fallen to the floor.
Examine panel.
The control panel is labeled Transformation Matrix Prototype. It features numbers in a 3x3 matrix. Each number in the top row has a slider above it that controls the setting of that number. The numbers in the second and third rows, though, seem to be fixed. A button is next to the 3x3 matrix. The matrix currently looks like this: 0, -1, 0, 1, 0, 0, 0, 0, 1.
Put book on platform.
You put your math book on the platform.
Push button.
You push the button, and a shimmering light envelops the platform. Your math book transforms so that it is now rotated 90 degrees counterclockwise. Your math book tentatively holds its new position for a couple of seconds before reverting to its original state.
One of the games it's just called Machine Rooms. There's a strange, complicated-looking machine in the center of the room. There's a golden path that leads out of the room that doesn't appear to make any sense, at least at first.
Look.
Machine room. Brass wheels, gears, knobs, and pipes emitting smoke are everywhere. This is a room out of some steampunk's dream. The south end of the room opens onto a gold-colored path. This path appears to be suspended in the air, with no apparent support, and to run for as far as you can see. You may also exit west. The room is dominated by a large, complicated-looking machine in its center.
Examine machine.
The machine is just as steampunk as everything else here, although there are several parts to it that look at least somewhat recognizable. For one, the machine has a switch that can be set to sequence or series. It is currently set to sequence, although you could easily move it to the other setting by flipping the switch. There is a button labeled alternate that is currently pushed off. The machine also has a dial that can be set to constant, identity, squared, or reciprocal. It is currently set to constant. There is a small circular hole near the button. Finally, there is a warning light on top of the machine. The warning light is dark.
Go south.
As you approach the golden path, you take another look at it. The path is level with the floor of the room you are currently in. It consists of golden steps that seem to run on forever. Each step has 2 numbers appearing on it, although from here you can only read the numbers on the 6 closest steps. The first numbers on the steps are all the same: 1, 1, 1, 1, 1, and 1. The second numbers are the same as the first numbers: 1, 1, 1, 1, 1, and 1.
What you'll eventually find out as you play with the different parts of the machine is that the machine controls this golden path. And then hopefully, by sort of watching what's happening, watching this path change, you start to realize that the machine is an implementation of various infinite sequences or infinite series. And if you have the right object with you, you can use the machine and the path to travel to various locations. So, for example, if you set the components of the machine up so that you have a sequence whose limiting value is 1, you can travel along the path to a manifestation of the number 1. What are some other ones? Sure. Okay, so here's another one. In this particular room, you walk in the room, and at first there's nothing but a laser bike in the room and a couple of instructions. And it's like, what is this thing doing here? So if the player does the sort of natural thing, which is to climb on the bike, it sort of shoots off into this space that has a grid. And by traveling with the laser bike along the grid lines, you are lighting up different portions of the grid. As you navigate this grid, you can't go back on yourself and run into a grid line or a grid intersection point that you've already been to.
Intersection. On the laser bike. You are riding a laser bike, traveling rapidly south through an intersection. Dark blue neon walls surround the intersection, but there are grid lines that lead north, south, east, and west. However, the grid lines to the north and west are lit up by beams of light.
Go west.
You give the laser bike a sharp turn west. When you enter the beam of light in the grid line to the west, though, the bike explodes. You hit the ground hard. Before you lose consciousness, you hear a mechanical voice intone, "Game over." When you wake up, you find yourself back in neon-lit room. The floor and ceiling of this room are black, while the walls feature eerie, pulsating, dark blue neon lights. An exit leads west. A sleek laser bike is parked in the center of the room. Someone has left a crudely drawn comic on the floor.
Read comic.
The comic consists simply of 2 pictures, a man singing Christmas carols and a man wearing an old Houston football jersey. The Euler has a large red X next to him, while the Euler sports a large green check mark.
Sit on bike.
You mount the laser bike. The expected door slides open in the east wall, and the laser bike shoots through it. You briefly catch a glimpse of a grid laid out before you, with intersection points, lines connecting them, and several ramps scattered throughout the intersections. A mechanical voice intones, "Starting new game. Illuminate all grid lines. Intersections will not be illuminated. 1 ramp jump allowed." Then the bike launches into space, coming down in intersection. On the laser bike. You are riding a laser bike, traveling rapidly east through an intersection. Dark blue neon walls surround the intersection, but there are grid lines that lead northeast, south, southeast, and east.
What I had in my head is the old video game Tron that maybe you or some people listening to the podcast might remember. There's a light cycle part of the game Tron that is very similar to this. But what you're doing in this particular room is that you're trying to light up all the grid lines without hitting one of the ones you've already been to. And anybody who knows a little bit of graph theory will probably recognize that what you're trying to do is to create an Euler circuit in the graph.
While knowing what an Euler circuit is would definitely make this puzzle easier, Mike was more interested in players showing off their mathematical reasoning skills than showing off how many names of mathematicians and types of mathematics they know.
My hope was that people who've never heard of Euler circuits would be able to solve the puzzle anyway, just by thinking through the way the grid is set up and what needs to work.
Not all the game is strictly puzzle-based either. There are also characters you run into during A Beauty Cold and Austere whom you can interact with. And sticking with the mathematics history theme, most of these characters are historical mathematicians. For example, early on in the game, you meet Euclid, who is looking for your help with something. But not all of the mathematicians you meet were included for game mechanics reasons.
I thought it would be fun for the player to be able to play poker with Pascal and Kolmogorov and Diaconis and Bayes, who are, four of the great probabilists of the last several centuries. Maybe the player won't stop to think about that, or maybe the player won't realize that they're these great probabilists. But I got a kick out of imagining the player actually playing and eventually defeating these four guys in a gambling game, poker game.
That was not the only thing that Mike did for fun. In the grand tradition of game designers, Mike also embedded Easter eggs in A Beauty Cold and Austere.
One of the problems you have to deal with in a lot of these interactive fiction games is inventory management. You pick up all these objects and, physically someone actually can't carry them. So some games have implemented another sort of container object that you can carry all your stuff around in. And so I decided I was going to do a container object in A Beauty Cold and Austere, and I was trying to think of what would be a mathematically appropriate container object. And eventually I thought, a set, of course. We'll just have the player find an empty set, and then the player can put all of their stuff in the empty set. And, a set can hold as much stuff as you want to put into it. But if the player is now carrying around an empty set, well, what can you do? What happens if you try to do things with it?
0. This is more of an abstract space than a physical place. Besides the hole leading up, you sense nothing here. Well, actually, you can see an empty set.
Examine set.
It's just a pair of curly braces. You could probably put things into it.
Open set.
Nice try. The empty set is both closed and open under any topology. Of course, you skipped that lecture.
Put set in set.
If you put the empty set into itself, would it still be empty? Fearful of creating some nasty set theory paradox, you refrain.
Put book in set.
You put your math book into the set.
Close set.
Which topology are you working in? Actually, that was rhetorical.
Put set in set.
Ernst Zermelo and Abraham Frankel materialize from nowhere and give you a stern look. That would violate the axiom of regularity, Zermelo says, while Frankel gives you a slap on the wrist. Next time, please try to avoid set theory paradoxes, they intone in unison before disappearing.
So that's an example of some Easter eggs that I put in the game, mathematical in-jokes. So most of the Easter eggs are pretty much all mathematical in-jokes.
And that is all the time we have for this episode of Relatively Prime. I want to thank Mike Spivey for giving me so much of his time and for dealing with some technical difficulties when we were trying to record this interview. I also want to thank the Mathematical Association of America for MathFest, where I originally heard about A Beauty Cold and Austere, and where I originally met Mike. Without MathFest, this story never would have come together. Also, I need to give a really, really extra special thanks to Bree Prehn and Katie Howard for being the voices of A Beauty Cold and Austere. Speaking of, if you want to play A Beauty Cold and Austere by Mike Spivey, head on over to Rel Prime ABCAA, which is the URL for this episode of Relatively Prime, and there will be a link there to play the game. Once again, that's relprime.com/ABCAA. Finally, I want to thank Sepgill and Broke for Free for the music that I used in this episode. You can find them over at SoundCloud or links from the show page for this episode of Rel Prime. Now, I also need to say something to the group of people without whom this episode would never happen. As a matter of fact, the show would never happen, and that is, of course, my patrons on Patreon. They are simply the best people in the world because I get to do this because of them. If you want to join their number, you can head on over to patreon.com/relprime or relprime.com/support and give whatever you can for each episode so that this show can keep on existing. If money isn't in the cards, I totally get it. I have been there more than once in my life. A few of those times because of this very show. And there is still a way that you can help out. You can head on over to iTunes, Apple Podcast Store, or whatever your podcast listening method of choice is, and leave a rating or a review of this show. This helps feed into some algorithms and stuff that can change where Relatively Prime shows up and can help more people find the show. All of this said, I still need to mention that Relatively Prime is a Creative Commons Attribution Share Alike licensed podcast, which means that you can take all of these words, take anything you want, remix it, as long as you share it in the same way and you give credit by saying that you got those sounds from Relatively Prime. Now, I think that that is just about it, except for the last thing. The one thing that we always close this show out on, which is, of course, me wishing you a matherific week, y'all.